In the world of AI, everybody is talking about AI, building agents, every simple task, whether it's a data engineering task or maybe any healthcare industry or any airline industry. Everybody is talking about AI and everybody is trying to build agents so that they can automate their tasks in an efficient way, right? So in this session, okay, we are going to talk about agents in detail. We will understand the terminologies, jargons that are involved in building agents, so that this video is going to be a backbone or a foundation for your agents or agentic AI journey. Hey everyone, this is Viresh. Welcome back to my channel and let's get started. So today we will discuss about most of the terminologies, may not be in detail, but at least we'll touch upon the terminologies so that we can, when we look at those in a practical way, you will be able to relate and understand what they are and where it is used, right? So first, when we talk about agents, let's understand what is an agent. An agent is an entity that you are trying to build so that you can offload your work and it can take a decision on behalf of you to do any task. So that is nothing but an agent. Okay, let's say you give this example. I'm going to use it again and again. Let's assume that you have written some functions to multiply, add, subtract, etc., and you write a prompt or you write a question, multiply 2 into 3. So instead of you writing, a human writing an answer to it, an agent can find an answer for it and then reply for it, right? So that can be done via agents, right? And second, we are going to understand the model is nothing but a large language model which has been trained with on a huge amount of data. We have so many LLMs that are available with respect to Gemini, Claude, OpenAI, etc., right? This is nothing but a brain, we can say brain behind agent. Without this LLM model, right, an agentic AI cannot do anything. All right, so we need to have this brain to be configured inside your agents so that it can take understand your requests which you going to write it in a normal natural language, do some processing and then return it in a proper way, right? So how model is going to understand what you're writing? That is nothing but prompt. What is prompt? It's a guidelines that you're giving to the model so that it can work according to your guidelines, according to your instructions, and give a proper result. It should follow your guidelines, your instructions, so that it will not deviate from the result and give wrong results to it. So that is nothing but a prompt. All right. So fourth one that we have is system prompt. Okay, this is also a kind of a guideline, but what it does is, we with this system prompt we are going to set the role or priorities, right, to the agent or the LLM, right? The system prompt, usually what we are going to say is, I want you to act as a senior data engineer or senior AI engineer and answer to the question. So we are setting the role of it, right? The template, the protocol that it has to follow and it has to behave. That is what the system prompt will do. All right. So next, fifth one is that what we are going to understand is tool. Okay, tool is nothing but a function or the activity that your agent is going to perform, right? It is nothing but a function that you are going to write, and it will be called via the tool, so that an agent can perform the activities that you have requested, right? How we are going to, in our demos, we're going to see any definition, a function that you write, let's say multiply, okay, a comma b, and it is going to return uh, let's say float, and then return a star b. And how we are going to convert this function into a tool? By a decorator called tool, right? That's all. This is nothing but a tool, right? And this access we are going to give it to the agent, so that if agent understands that I have a tool, then it is going to call that tool. If not, then this model is capable of giving its own answer, and it will find its own answer and then give it. But again, we can give a system prompt or a prompt to use first available tool. We might decide that if you don't have a tool access, then return nothing. But we might also say that if you have a tool access, if you don't have a tool, then you can find your answers and then give it to us, right? That is a tool. And sixth one that you have is word is tool calling. This tool that we have written, okay, how you are going to call within the LLM is nothing but tool calling, right? If LLM or the agent knows that we are going to bind our tools to that agent, and agent knows that I have this tool available based on the keyword, or that's what the LLM's job is about, right? If that agent knows that I have a tool, then it will call that. If not, then it is going to get the answers from the outside with the knowledge that LLM has. All right. So next is we have observation. Observation. This is the behavior or the way agent will work. Okay. Observation is nothing but the understanding of the output that it is getting after each tool, each iteration, right? It will observe the answers that the tool is giving, and then if it is matching to the requirement of the user, then it is going to return it. If it is not, then it has to repeat it, right? It has to repeat it, right? How it is going to run? It is going to be done via the action. Okay, action is nothing but whether to call a tool or not to call a tool, or whether to execute it based on the observation, is nothing but an action, right? Usually how agent works is, of course, it comes in the later part of section. First, it will uh, it will observe, okay, and then action, and then what else it will do? I'm going wrong here. Sorry, it will do reasoning. Reasoning, observe, action. Okay. Then ninth one is agentic loop. So what is the agentic loop? How agent will work, right? Whenever a request comes to it, what all steps it will follow, from the time you write a question to the time it returns the answer. How the agent works is nothing but agentic loop. How it does is, whenever any request will come, first it will think, okay, whether I have the right tool or not, whether to go with which tool, or should I go and fetch the result from my own knowledge, right? And it thinks and then decides it. After decision, it will take an action, and then it will observe, and then it will repeat. So this is how the agentic loop keeps on repeating until it gets the desired result. All right. So this is the agentic loop, right? So next we are going to understand is state. Okay. Afterwards we have the context. Okay. State is nothing but, let's say you give a question to the LLM or the agent, and it is processing. It will show you if you have used Claude or Gemini. When you give an question, it will think, right? It shows some processing that it is doing. It is hitting that server, this server, and so on, right? So that memory or the information that it preserves during the execution or the workflow of an agent is nothing but state, right? But once the workflow is completed, once it gives the result, then there is no state for it, right? It is during the working or the workflow execution time, whatever the information that it has, that is called as state. But when it comes to context, it is the entire knowledge base that the agent has. It could be the system prompt, it could be the user prompt, it could be the conversational history, a information or the prompt from the external agents, etc. Put together, it forms as a context. At any information that is available to the agent at a given point in time is nothing but the context. Based on this only the agent is going to answer properly. All right. So this is context. Next we will see the short term memory. Short term memory, and third one we have long term memory. This short term memory, it is with respect to the conversation that you are having. Okay, it is with respect to the conversation or a session that you're going to have. So it is going to remember that session, conversation or context only. Let's say in this conversation you ask, my name is Viresh. Okay, you close that conversation, and then if you open one more conversation and ask what is my name, then it doesn't remember that. Okay, so that is the short term memory, which is valid only for that particular session. Okay, and long term memory is nothing but it remembers your previous history as well. It is going to store in the database, or maybe we can set up to, it can remember up to 5 conversations or last 3 or 5 conversations, etc. And it can remember, and when you ask a question, so it is going to get from its memory, its backend database, and then going to return. In case if you have observed, whenever you are interacting with any LLM model like Claude, Sonnet or Gemini, etc., you would have interacted with it like last week or something about any agentic AI concept or the AI concept. But if you ask a question today, then based on the conversation that it had previously, it is going to return that you are interested in learning about agentic AI and this is what it founds, and etc. All those things, answers will come. All right. So that is about long term memory. When it comes to context, there is one more word that it comes to is context engineering. Okay. Context engineering is nothing but when you are going to have a conversation with the agent, you would have had a lot of conversation. It you would have given a lot of inputs, information, retries, etc. Right? So if you let the agent know what context it should access, what context it should not, right? What is the right information? What is the wrong information? If you could restrict the agent to that, what context it could access and what context it should not remember, so that it can give result without hallucinating, right? It's basically the way we can limit the context it has access to, so that it can give us the proper accurate answer without hallucination is nothing but context engineering. We could restrict the results from a tool, we could restrict the previous conversation, right? That is why if you also understand, we have write some MD files for any Claude or other LLMs, right? So we give proper instruction that you have to access first this readme MD file. If you don't find an answer or the information in this MD file, you don't have to go and search outside or give me wrong answers. If it is not there, then you tell me it is not there, then I can give the inputs where to look at it. So that is how we will limit the information that an agent can process, so that we can save in terms of tokens, or we can save in terms of the agent giving wrong answers. All right. So then coming back to this one, we have another term called checkpointing. As you all know, it's nothing but at any given point in time, if you want to store that result in memory, okay, or a snapshot of it, is nothing but checkpointing, so that the agent need not to reprocess it again and again, right? So this is nothing but the checkpointing, right? Then we have something called thread. Thread is nothing but the current conversation that you are going to have, right? If you the active thread basically, right? In any LLM model, right, you would have opened multiple conversations, you will see multiple tabs, right? So it's nothing but one thread. So thread is nothing but the current active conversation that you are going to have, is nothing but the thread. Then we have the node, edges, conditional edges. So what are we going to do here is, so these basically it comes in terms of the agentic stuffs, okay? So what we do, node is nothing but this is one node, this is one node, and this is one node. This is nothing but edges. All right. So in a graph way, right? So this is nothing but one agent, this is nothing but one agent, and this is nothing but one agent. But the let's say, one second. Yeah, let's say from this node, a response is coming to this node, okay? From A it is coming to B. B is going to decide based on the output whether to go with node C or node D. These are nothing but the edges, these are nothing but the conditional edges, so that based on the condition that it satisfies, the it will route to the next node, okay? These are with respect to line graph, which we are going to see it in the demo coding exercise afterwards. All right. So next we have router is nothing but let's say we have a agent node, multiple agent is there, and then it has access to multiple tools, right? I give a question to it, right? Multiply 2 into 3, right? a route, what it does is let's say this is the route, okay, start of it. Comes here, come on, then it goes to this. Okay, so this is the router. Let's assume this is one agent. Okay, a user request will come from here. If it is, let's say, the word multiply is there, then it has to go to this rule, because this node, because it is performing multiplication. If it is, let's say, I sent addition, then it will go to this one. Similarly it's on. So this is a router. It will route to the proper node based on the information that it has. Okay, this is the router. Next, what else we have? React. Okay, React is nothing but, in agentic terms, right, any agent that you give, so it first it does is reasoning. Okay, it does the reasoning, and then it takes the action, and it will observe the output it comes, and then it will repeat. Okay, so this is what the reaction is all about. It's called reacting agent. Okay, react agent, right? So we're going to talk about this in detail, right? So this is about react. And then we have something called planning. Planning is nothing but breaking a task that is given into manageable subtasks. Is nothing but planning. How you plan, for example, if you are designing a project, if you are going to develop a project, you are going to start doing everything at a time, right? You will plan it, you will divide it accordingly, manageable daily tasks, weekly tasks, monthly, and then quarterly, and then yearly, and then complete the project. Similarly, even agent also, it will plan, and then it will divide it into manageable chunks, and then give us the output. Is nothing, that is what is planning. Okay, and next we have reflection. Okay, so reflection is nothing but, let's say this output is there. Okay, let's say it is, you gave a question. Okay, it is return the multiplication. Okay, afterwards what we can do is, we can have a one more node which can reflect on the answer. Okay, this is nothing but reflection, right? It will critique the answers given by it himself, so that it will validate again. It does the same thing, it will take the action, it will observe, and then it will critique if it is not meeting the requirements of the user as per the prompt, and it will repeat again. So this is where the reflection will come into picture. All right, so then next we have something called supervisor. And then we have the worker. Okay, supervisor is nothing but an agent which will supervise the work of the other agents. Okay, it can make sure that, it knows is, what agent can do which activity, right? So that it can handle, it can route or give the work to that particular agent, right? One agent will control the behavior and the work of the another agent. Okay, so that is nothing but, again, it comes to the same. This is the, if it is the supervisor, okay, and it is going to be the worker, so it knows which Okay, it knows which node does what activity. That's why it is called a supervisor. And worker is nothing but a specialized agent to do only that particular activity for which it is designed to be done. Okay, for example, if this worker node, it does the coding, it can only do coding. Okay, let's say coding is a general word. Let us take this work knows only SQL, then it can do only SQL, nothing else. If this agent knows Java, it can only code in Java. If this does in Python, etc. So these are all workers because they are designed to do specific activities only. Okay, that's why they are called as workers. All right. Next one we have is nothing but handoff. Handoff is, let's say we have a agent. Okay, it does part of the work, right, and then it will hand off that entire work to another agent so that that agent can take the inputs from the first agent and then carry forward the other work. It's like a kind of a relay that you give the stick that is in your hand to the next person, and then that person will take it forward, right. It is nothing but handing off the work that is done by the agent, one agent to another agent. Okay, so next thing that we have is guardrail. Okay, guardrails are nothing but the conditions or the restrictions and the rules that we put on the agent so that it can follow the our rules, and it will limit to the information that we need rather than going out of the box and then giving some random answers, and finally it is resulting into loss of tokens and loss of time, efforts, etc. So basically the guardrail, we set it and give instructions to the agent that before you start work, right, you go to that rules.md file and then read the rule. If you are going anything out of the instructions mentioned over there, you bring back and then read that again, or ask prompt whether can I do it or not. That's where human in the loop will come into picture, right. That's where let's say human in the loop, let's say agent will do some activity, and then if it has to update any file in the rule.md file, we would have mentioned if you are at any given point of time making any changes to our code file, right, you have to ask me for approval. So then it will wait, ask for approval, and then it will wait, it will show what changes that it is doing. We have to review that, and then if you click on OK or approve, then it is going to make an update. So that's where these two comes into picture, guardrail and HITL. Okay, human in the loop. Next one that we have is structured output. Okay, so structured output is nothing but let's say you have one agent. Okay, this is one agent, and this is another agent, and this is another agent, right. So this, how they are connected, it will perform some action. Okay, yeah, it will perform some action, and then it will give the output. It will perform some action, it will give the output. This has to take the input and then take it forward. But the output that it comes, right, so this will be let's say it is expecting in the JSON format, and this is expecting in the XML format. So then this agent should return the output in the JSON format. This second agent should return the output in the XML format. So that is why we call it as the output should be in the structured. When we say structured output, that is what it means. Okay. Next we have streaming. Okay, streaming is nothing but, as the word itself suggests, so the data that comes in, like a token that is generated, or the information or the output generated from one agent, it should emit as and when it has the information, bit by bit, or byte by byte, etc. As and when it generates any token or inputs, it has to pass it to the next agent rather than waiting it for processing entirely and then passing it as a batch. Okay, that's why it is called as streaming. So next we have what next terminology is RAG. Okay, retrieval augment generation. Okay, so what it does is, agent um, will talk to my own data and then give the information to us. Okay, so basically let's assume that we have some documents. Okay, we have some documents. We will be, before RAG, what we will do, we will be giving it to some embedding modeler. Okay, and then it will be storing it into some vector DB. Our documents are made in terms of chunks and etc. I'm not going into much detail, but this is the high level of it. Okay, now vector DB is there. Now let us assume that we have our LLM here. Okay, if you ask any question to LLM, okay, first what it does is it will go to this embedding, get the information from vector DB, and it will search, find its own answers from the internet based on this, and then it will result this. So that's how it is called as retrieval augment generation. It is dependent on the data that is having. It will get the information from the vector DB, the data that is there, and then it will find the answers to based on that, and then it will give the results. Okay, this is RAG, right? And next we have something called agentic RAG. Right, agentic RAG is nothing but the agents. We will decide, right now we have writing, we will, an user will be writing it, and then LLM has access to our embeddings or chunks or the data that we have in vector DB, and it will have access to only this data. Okay, it will have access to only this data, and it will give result based on this. But when we have an agentic RAG, we will give decision is left to agent. It will decide whether the information, the result output it should give based on the data that is available in the vector DB, or based on the information that is available to itself. It can get it from outside, search in the web, and then give the results, or maybe the other agents, input from other agents it can take. So that decision, how it has to give me the information or results to my question, is dependent on the agents that we have developed based on the RAG application. That means what I'm trying to say is the agents will decide when and how an answers will be or results will be given to the user. That is nothing but agentic RAG, and this is quite famous nowadays. Okay, then we have something called MCP, which is again quite famous in the industry nowadays, which is nothing but model context protocol. Right, like how we have the HTTP protocol and HTTP REST API protocols, etc. It is nothing but the rule that is set to have a connection, or sorry, communication between the two different agents. For example, I have a from my agentic application, I am connecting to an camera. It's a IoT device, right? So how I can make a connection, communication between that? There has to be some format, some protocols, some rules and regulations that we have to follow. So that is nothing but the MCP, model context protocol. And if I design any model context protocol, I can give it to my agent, right? I can have a configure it in such a way that my agent first will hit the MCP protocol, model context protocol, and then it will does it activity and then gives the answer. So basically the way we can control the how it is communicated, how the information is communicated between multiple agents, is nothing but MCP. Next we have harness. Harness is nothing but it is the infrastructure that we have around the model that we have, right? What I mean to say is, let's say in any agentic system, right? So model is the brain behind it, but around it what we have, like tool calling, and then the system prompt, user prompt, and then the conditional tool conditions, etc., right? These are all the infrastructure, the infra that we have around the agentic, around the model is called harness. Like in for example, if in a layman terms, if I have to explain, let's say you have a car, right? Engine is the model, which is the heart, right, or the brain of it. Rest all, whatever you see, the tires, the steering, seats, the body, clutch plates, etc., music system, etc., is nothing but the mm, infra of it, and which is the combined is nothing but a harness. All right. So these are the terminologies so far, mostly used. Okay, I've just touched upon few of the these terminologies, but we need to go dig deeper to understand it, so that if any interview, if they asked, we should be able to answer them with example. Okay, I hope this is you find it helpful. Okay, if you have any questions or queries, please feel free to um, write it in the comment box, and if you want me to cover something else in detail, please do let me know. I'd be happy to do that. Okay, with that, thank you so much, and see you in the next video.